What is going on, everybody? It's me, it's Original Gamer Stevie Stroh, and we're back for yet another exciting chapter in Programming in Basic on the color computer. Alright, well, we are now going to be looking at Chapter 24 in the book, which is called Play It Again TRS-80, and this is going to help us cover and understand the play command, which is an improved way to not only generate music and play musical notes for those of you who are musically literate, but for my interest, since I'm going to be working on developing a game in the near future, is it's a great way to use BASIC to generate some sound effects that sound better than what you get out of the normal sound command. So let's see what the good book here has to say for us today. So it says, so you think your computer's a pretty good artist, huh? Well, you haven't heard anything yet. Wait until you find out about its musical talents. Ready? Then let's get down to work and play. Ha ha ha, very punny. Your computer's play functions allow you to not only play music, but to compose it as well. Now, play, of course, is not a graphics function. Therefore, you don't need to preface your programs with P mode, PCLS, or screen, right? So this is an audible command, so it's irrelevant of what graphics mode you're in or aren't in. And here is kind of the breakdown to the play command. It's play followed by music. What makes up music? Well, you can specify notes, and you can specify notes by the letters of the alphabet. So if you know the notes, you know, like A, B, C, D, E, F, G, you can specify those notes, but you can also specify numbers. And as it turns out, on a piano, a single octave, which is from C to whatever that last letter is, I forgot, plus all the black keys in between, means there's actually 12 notes in one octave. And so you can specify each of those notes numerically between 1 and 12, and then you have a total of 5 octaves. There's a 5-octave range you can go through with all 12 notes. So for a total of, if you do the math, 60 notes, right? Now, as you go to play each note, you can specify the length of an individual note. Length 1 would be the shortest, which is, and then length 255 would be the longest. Tempo, you can also specify the tempo, again, between 1 and 255. The smaller the number, the slower the tempo, the bigger the number, the faster the tempo. This is something we did not have the ability to do with the sound command. Is we can actually change the volume of an individual note, and so you can kind of get some neat effects there. And you can also insert pauses between notes, so if you need to pause for a beat or more, you can do that. And then, much like the draw command, you can create strings of music and then have the play command call these strings that are called substrings, so you can execute substrings. So that's kind of the introduction to the syntax of the play command. The chapter will break us through some more of it. So it says, obviously you can't have music without notes. Play gives you 2 ways to specify the precise note you need. The first and probably easier way to play a note you want to is to enter one of the standard musical notes, A, B, C, D, E, F, or G. To indicate a sharp note, follow it by the plus sign or with the pound sign. So like A pound, or like C sharp, right? Programming language. So C pound sign would be C sharp. To indicate a flat, you would do a minus sign, right? So so in order to play the command, you could play like A and A sharp, right? So we can try that real quick right now. We'll just go into our little basic prompt here.
Hi, this is John Linville.
And Neil Blanchard.
We are the CoCo crew. I hope you're enjoying watching Stevie Stroh play video games, especially the CoCo games. And when you're done with that, check out our podcast at cococrew.org.
Let's try the play command. So if I type in play A, there's the A note. If I type in play A and A sharp, so you hear the dun-dun, sounds like Jaws, right? And then if I do something like play A flat, and then A sharp, and then A flat, it's going to sound like I'm playing the theme from Jaws here. It's going or maybe not. Okay, shows you how well I was able to read that, huh? So that is playing the A key back and forth between the black and white combinations. It says you can do the same thing with all 7 notes on the scale except for B and C. Since it says B sharp equals C, you must use C. Likewise, since C flat equals B, you must use B. It says a new notation. Ha ha ha. You see how they did that? A new notation. Yeah, so it says another way to specify musical notes is to use the numbers between 1 and 12 prefaced by the letter N. So N1, N2, N3, N4, right? And so it says the play command does not recognize the notation B sharp or C flat. Use the numbers 1 and 12 respectively, or substitute C for B sharp and B for C flat. So now it says to hear a 12-note scale. So right now we're going to load scales. And so now I'm going to show you the program that's kind of in the book and the examples in the DIY examples. So in the book, it starts off by having us do an ascending scale where we go from 1 to 12. So we're starting low and then we're going to go higher. It has us pause for a few seconds so we can see the note number and then listen to the note, and then it finishes this. So we're basically doing a for next loop here. For note equals 1 to 12. Print note number, semicolon N. We'll print that number on the screen so we know where N is within the loop. Play strings, str strings N. That converts a numeric variable into a string variable, playing that note, and then next N just goes through the loop. I then just put in a little line here to pause. A strings equals increase string, and then just wait for you to press a key. And then I did the same thing in reverse to do a descending scale, which was the next thing that the book had us do. It says try to do this in reverse. Do it yourself, right? So here's what this little program sounds like, and you can see here it's literally 14 lines, and it all fits on the screen. So here's our ascending scale, meaning going from low to high, and then our descending scale going from high to low. All right, so that was from low to high. Let's listen to high to low. All right, so that was an entire octave. There's a total of 12 notes in a single octave, and we just went through all the keys up and then all the keys down to be like going and on your keyboard if you had an actual musical keyboard. And here you can actually see the notes, okay? So this is note 1, this is C, and then here's our note 2, which would be C sharp, and then we have D, and then we have D sharp, and then we have E, or this would technically be, I don't know, is that E flat? Then you have F, F sharp, G, G sharp, A sharp, B flat, C. All right, C starts a new octave. So 1 through 12 is one octave here. So this is kind of showing you where the notes factor in on the keyboard, right? And so it says modify the scale so it goes down instead of up. Now I kind of already did that in my little program. And now it gets into notes, half notes, and quarter notes by using the length command. And so here's where the length command factors into the length of a note. And if you're, again, I am not musically literate, so for those of you who are, this will make more sense. I am not going to attempt to teach you how music works, music theory, or anything else like that, because I don't know those things, but I will try to at least show you how this command works. So L1 is a whole note. You know, I know there's whole notes, half notes. There's a dotted quarter note, right? There's an eighth note, a quarter note, there's a 16th note, right? So you can, length 64 is up to a 16th note, and then if you get up to length 255, that is 1/255th of a note. That's the shortest sound you can use in BASIC, right? Love the dotted note. So it says if you read music, you already know about dotted notes. The dot tells you to increase the length of the note by 1/2 of its normal value. For example, a dotted quarter note is equal to a 3/8 note. Okay, and here's the mathematical formula if you don't believe them. So, if you do an L4 dot, that is a 1/4 plus a 1/8, which is a 3/8. And so this is showing you an example of doing an L4 dot for the length if you need some precise stuff. So if you wanted to compose or transpose sheet music, you could do that with this command. And then it says, let's go up or down an octave or two, right? So single octave 2 sounds fine, but we can change the octaves and we can go higher and we can go lower by using the O command for octave. And again, there's a total of 5 octaves. So in the book, they will teach you how to play certain notes and how to change different octaves and go up different notes. And then it gets into the V command for volume. So it says play it again and play it louder. So first it introduces us to playing the note A several times, but increasing the volume as we go through here. So we can go from volume 5 to 10 to 15 to 20 to 25 to 30. Remember, the volume command, I think, is from 0 to 31, so there's a total of 32 volume options. So this little mini program here would have us just change our volume. And then it gets into showing us how the pause command works, and we can put in a pause in between notes. And then here's where it shows us how we can change the tempo of this. So it's showing us this is our current program, but if we were to change the tempo to 1, it would be slower. And I'll show you that in my demo as well. Okay, here's the first half of the program. So I basically took all the different sections in the book and did them. But I kind of printed a little description on the screen as I'm doing each one. So the first thing we'll print on here is we're going to say print volume rising. And this is where we're going to, and I also defaulted the tempo to tempo 2. Volume 5, play note A. Volume 10, play note A. Volume 20, play note A. So you're going to hear the same note getting louder, 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 louder as it goes through. And then put a little routine to pause in between here. And then this is the same thing where they said, well, now that you've played with the volume, let's introduce you to the pause command. And it's the same notes now with a 2-count pause in between each note. And then I introduced changing tempo to 1. And so the default tempo is 2. When you change the tempo to 1, you've basically now slowed things down even more, and so you're going to hear the same notes and the same volume thing being played louder but slower. And then just for grins and giggles, I also did one where I changed the tempo to 10, and so you're going to hear them play even faster, and then the program will end. And this is my little delay. Every time I want to pause for a minute, I go sub this routine to count to 600. So here's those little sections in the chapter right here. This is introducing us to volume, pausing, and tempo. You hear it's much longer now. And when I changed the tempo to 10, it went much faster. So this is a little mini program here that's doing some of the stuff that was in that chapter, but rather than having me retype and rewrite it each time, I just made it a little bit longer of a program to show you all the variants the book was covering. This will be saved on my disk image, and I will upload this to my blog. So when you check out chapter 24 in my blog, if you want to download the disk image, you are welcome to do that. Executing the substring. So in this little program here, what we've done here is we've defined an A string. And so A string prints A sharp, and then A flat. And so that's my da-na-na, well, however that goes. B string says octave 5, execute A string. So it's going to take these notes and play them in octave 5. And then C string says, well, go to octave 1 and execute the A string, which is that little thing there. And then it also says execute B strings, which is going to be an octave 5 of A string. So what we're going to hear is an octave 1 of those 3 notes and an octave 5 of those 3 notes. But we're doing it in a kind of unique roundabout way where we're hacking how the command works here. So here it is, right? So once again, so A string has 3 A notes. So it's A sharp, A flat. B string says, well, go to octave 5 and execute A strings, which is those 3 notes. C string says, Go to octave 1, execute A strings, that's those 3 notes, and then go to execute B strings, which goes into octave 5, and here's that. So you're going to hear the same 3 notes twice, once in a low octave, once in a high octave. And so let's hear how this sounds. That was both ends of the spectrum. That's kind of showing you how you can take the same note and play it in different octaves, which raises it up by a factor of 12. So it says one further note. So now we're not going to spring a new note like H or J on you, but we have one final way you can use some of the play options with octave, volume and tempo, and length. You can use one of the following suffixes instead of a numeral. Ooh, I like that, right? Minus will subtract 1 note, greater than multiplies by 2, and less than divides by 2. So that's pretty interesting. So plus and minus. So T plus will increase the tempo, T minus. So you can, so this is also, I guess you could do like some 4 next loops and change your volumes and stuff like that. That is actually pretty cool. I'm not going to go through all of those, but I think you get the idea here. Now it says, roll over, Beethoven. After all the hard work you've done lately, you deserve a serenade. And so when we get onto page 140, we get into a cool little demo that plays the tune When the Saints Go Marching In. So it all kind of fits on the page here. And I've gone ahead and, again, typed it in for us ahead of time so you don't have to sit here and watch me struggle with the keyboard. So list through 50, you're going to see some of the stuff here. So we're going to, some of it's printing the strings across. It's printing in the border and the title of the song, When the Saints Go Marching In. It pauses. Line 50 through 100 is kind of showing you where it's printing the lyrics on the screen. So the lyrics of the song is here. And then line 100 through is list 100 through. We're going to kind of see it's got all the string data for the notes and for the different sections of the song. So they're all put together as A string, B string, C string, D string, and E string. And so they're defined as strings. And then we're saying that X strings is going to execute all the substrings. So it executes substring A string, executes substring B string, C string, D string, E string, etc. That string becomes one string that executes all the other strings, and then we play that. So it's kind of a cool way to break the song up into different strings, create a new string to call all those strings, and then play that string. Why? Because CoCo. And then when it's done, it's going to clear the screen, and it's going to say, play it again, CoCo. Well, I changed it to say CoCo because the book said, play it again, TRS-80. But we all know this thing's called the CoCo. And then it pauses, and then it's going to say, sure, I'd be glad to, and it pauses, and it goes back. So let's listen to When the Saints Go Marching In on the Top 40 Countdown. All right. Play it again, CoCo. I'd be glad to. Something's getting messed up there with the tempo or the something. I noticed that when it loops. Now, because it's in the middle of one string, I can't even break out of this string until it's done. Okay. I noticed with that when it loops, the next time it starts the song, something is slower, and I don't remember what got changed towards the end, and I was too lazy to check. But somehow the tempo or the length got changed on the last substring, where when we looped it over again, we started off slower. I tried looking into it. I couldn't quite find it. I'm like, you know what, dude, I'm not getting paid for this. So yeah, anyways, so this is that little program that's in the book. Again, this will be on my floppy image. It'll be on my blog, so you can download it from there. That's When the Saints Go Marching In. On the Top 40 Countdown, I'm your host, Casey Kasem. And then here we go. It says, what did we learn in Chapter 24? Well, we learned how to generate musical notes. We learned how to include dotted notes. We can determine note length. We can change octaves. We can adjust volume. We can pause between notes. We can change the tempo of notes. We can execute substrings. And we can use suffixes to give values relative to the current value. So I wish I actually read that little piece before and showed you a demo of that, but too late now. And I'm lazy. But I didn't leave you completely empty-handed here, because I did write a different demo that's not in the book, and it's more relevant to what I want to do, because I'm not a musician. For God's sakes, Jim, I'm not a musician. And I'm not going to probably make a lot of music in whatever game I do, although maybe a title song or something. But I am interested in using the play command to generate sound effects. And I did some of those. So I created a program called Sound Demo. So let's list through 4. So I print on the screen, play command demo. I've dimmed some strings. I've cleared some space. I've got some data statements in here that generate 1, 2, 3 different sound effects. And so you can kind of see here I'm setting the octave, the length, the tempo, the volume, and then I'm doing things here. And this one here, I think this was my kind of boink sound, like if you bumped into something, like a low frequency tone. So it's the same note C over and over again, but I go from volume 8 to 12, and then 8, and then down to 4. So it's kind of a rising and falling volume curve of the same note. So it's like a boom sound when you hit it. The next one here is a boink sound, which is just a higher frequency note. So I'm getting up to like volume 28, and then I'm doing 3 notes here. I'm doing 8, 10, and 12. I just kind of did it numerically and skipped by 2. So I did a volume 24, 8, a little bit louder, 10, a little bit louder volume, a little bit higher pitch, a little bit more volume, a little bit more pitch. So it's basically a high frequency sound. It's bink, that kind of just gets a little bit louder and higher pitched as it goes through. The third one here is, I forgot what this one was. So volume 2, 1, volume 4. Oh, this is my siren. Woo, woo, woo. That's my siren sound. So I have kind of a escalating volume and frequency, so it gets higher, and so it gets louder as it gets higher, and so it goes up one like the woo, and then it goes down lower, woo, where it starts off high and gets lower, and it decreases the volume on the way down. Now this one here, to create a the next sound here is actually a laser beam. And so it's like a boom, boom, which is like a low, like a high to low. It's like boom, boom, boom sound. So that's my laser beam sound. So I start off on octave 3. I do short lengths and short tempos for all of these, so it's a really fast sound, because you notice that when I was playing that song, I could not break out of it. The thing about the color computer is it uses the CPU to generate sound. So while sound's being made in BASIC, you cannot do anything. So you want your sounds to be very short so you can get back into the game cycles in between sounds. And so this is my laser beam sound, which is like a descending scale very quickly. Pew, pew, pew. And then on the next one here, I generated this randomly. I want to create an explosion, and rather than figuring out a bunch of individual notes to make an explosion sound, I start off on octave 1, the lowest octave, length 1, lowest length, tempo 255, the fastest tempo, volume 30, very loud. And then I do a 4 next loops to generate 24 notes, and each of these notes is going to be completely random between number 1 and 12. And then I take those random notes and I turn them into strings. And so I start off by saying my explosion string is this. It's octave 1, length 1, tempo 255, volume. I then start generating 24 random notes between 1 and 12. I then say, well, my explosion string is going to equal itself plus the new note plus the semicolon, and then finish. And then I insert that into sound strings 5, because all of these things are data statements that I'm reading in sound string 1, sound string 2, sound string 3, sound string 4, sound string 5. I've now got 5 different sound effects loaded into string arrays, and I can call them back at any given time throughout my program if I had the kind of these canned sound effects and I wanted to reuse them. And then starting on 11 through, I've got a little menu here kind of listing off what my sound effects are. So I've got sound 1 for bump, sound 2 for blip, sound 3 for siren, sound 4 for laser, sound 5 for an explosion. And then if you press the 9 key, it will exit. How do I make my menu system work? Well, I get my in-key strings. I turn that into a valuable, so I get a numeric variable based on the value of the key I pressed. And I basically said here, if it's greater than 0, meaning it's got to be at least 1, and it's less than 6. So basically this is saying if it's between the numbers 1 and 5, then play S string of whatever that number is. And then I say if it's 9, then end, and if it's anything else, it's just going to keep going back looking for a key. So what does that sound like? What does that look like? And there was a slight pause there as all the random numbers are being calculated and stuck into the string. But here's my bump sound if I press number 1. You hear that? It's just kind of a bump sound. It's the same note with just kind of a rising and falling volume, like I'm bumping into something. Here's my blip sound. So the blip sound. What is a blip sound? We know when you do a blip. Here's my siren. So it gets higher and louder, and then it goes from high to low and gets quieter on the way down. I probably could have put a pause in between the two, but whatever. And here's my laser sound, my pew pew. And the laser sound starts off high and just gets lower. I'm firing my laser. Oh no, the cops are coming. Damn cops. And oh crap, I bumped into something. And now I'm driving. I'm driving as I'm firing my laser. And oh crap, I just blew into something because there's my explosion sound effect, right? So that one actually sounds kind of cool, right? And I could have made that longer, but that's 24 very short, very low frequency tones played together on an explosion. So here we go. Here's our bump. Here's our blip. High frequency, short sound. Here's my siren. Here's our laser. And here's our explosion. Alright, so these are some basic arcadey game sound effects, all generated using the play command in strings. And that's all I care about. I want to make a game and I want some cheesy sounds to go in my cheesy games. And that's what I'm using the play command for. That's the hokey pokey, folks. That's what it's all about. And we're done with chapter 24. And we're getting closer to the end of the book, which means it's time for me to shut up and put up and start working on a game. And I'm still contemplating what games I want to make and all that kind of good stuff. But yeah, this was fun. And so I hope you have enjoyed chapter 24 on programming in BASIC on the color computer. I am the original gamer, Stevie Stroh, Mr. Gameplay Goodness himself. If you like what I do, and I don't do this for the money, I do it for the love of the CoCo. But if you want to show me some love, you can do that by going to my website and checking out one or both of my Gameplay Goodness CoCo DVDs featuring multiple hours of gameplay goodness videos for you to watch and enjoy. And for a limited time, right now between August 1st through August 5th, my DVDs will be half price on my website to celebrate the 20th episode of CoCo Talk, our weekly live talk show featuring the Tandy Color Computer. So trying to give back by giving a discount on what little bit of crap I have to offer. I have been the original gamer, Stevie Stroh. We have been programming in BASIC, and we'll see you on the next video. Peace out and bye-bye. CoCo forever, everybody.
Hi, I'm Mike Rowan, and you're watching the original gamer, Stevie Stroh.